Welcome to this lecture. In today's lecture, we will discuss about the Poisson effect. When you strain a body along one axis, it will change shape along the other axis. For example, this is the bar. So when we will apply the strain, this one along with this axis, we are applying this pressure or force in this axial direction. So it will stretch in this direction. So along with this, there will be change in the lateral dimensions also. The strain in the direction perpendicular to the axis has opposite sign or to that of the strain in the axial direction. If in this direction, if the length of this bar will increase, then the width or lateral dimensions of this bar will be decrease. So we can say that in this direction, in axial direction, the strain is positive. So in the lateral direction, that is perpendicular to this axis, and the strain will be negative. The strain in the perpendicular direction depends on what is called Poisson ratio. We can say there is a relation. There is a proportionality relation between the strain in the axial direction and in perpendicular direction. So we can say that Ey is proportional to Ex, and also Ez is proportional to Ex. So this is a proportionality constant that is called Poisson ratio. So we can say that Ey equals minus of E minus of mu into Ex, and also Ez equals minus mu into Ex. So this is the proportional constant that is known as Poisson ratio. The value of this Poisson ratio varies from 1 to 0.5. For plastic it is 0.5, and for metal, polysilicon and the silicon compound it is between 0.2 to 0.3 value. The new length of the bar after just stretching it, that will be, we can take, that is Lx dash. What is Lx dash? Original length plus addition of increasing the length. So L plus del x, you can write Lx dash. So this is Lx into 1 plus what is del x? Del x is minus is mu into epsilon x. So we can write Lx equal to 1 plus epsilon x. In the previous slide we have written this minus sign because we are stretching in this axial direction, so its length is increasing, and also with this the dimension in the lateral direction, that is perpendicular to this axial direction, the length dimension will decrease. So we are taking this negative sign. Here stress is negative. Here we can write the positive sign because the length in the x direction length is increasing. So we will write L dash x equals L plus del x, that is L plus Lx into epsilon x. This is we can write. So from the Poisson effect, the new length for the other directions, that is that will be Ly dash equals to Ly multiplied by 1 minus of Ey mu Ey and 1 minus of mu Ex and 1 minus of mu Ex into Lz for z direction. For the volume, what is the volume? The multiplication of all three dimensions. So the V is Lx plus Ly plus Lz. So del V, that is the change in the volume, that is the new volume minus previous volume. So new volume is Lx dash into Ly dash into Lz dash minus of Lx, Ly and Lz, that is the old previous original volume. So that will be, it will just give you the difference, that is the change in the volume. Or we can write from this using these equations, what is value of Lx dash, Lx Ly dash and Lz dash, that is that these value on putting this one we will get the values, the 1 plus Lx into Ly into Lz multiplied by 1 plus epsilon x, 1 minus mu epsilon x, 1 minus mu epsilon x minus 1, that is the original value. So this equation we will get. For a small strain value, when we will just opening this, we will multiply all this and we will see them some square terms also. So if there is a very small changes in the dimensions, so we can just ignore the higher power value of this ex. So we will get the del v approximately equals to lx into ly into lz multiplied by 1 minus 2v 2 mu into epsilon x, because the higher value we can neglect. Or we can write del v upon, this is in upon v, this is the original value of volume. So del v upon v equals to 1 minus mu into epsilon x, this is the value. By Hooke's law we can write the epsilon x equals to sigma x upon e, that's a strain equals to this stress multiplied by Young modulus. Or we can write this px upon, that is px is the pressure also, so pressure in per x direction upon Young modulus. So del v upon v equal to 1 minus 2 mu into px upon e. E is the Young modulus. The second consequence of the Poisson ratio considered here is for the case of a beam. What will be the effect in the beam? We write this equation epsilon x equal to minus y upon rho. We have already calculated, and there we will see that maximum value of epsilon x is minus c upon rho. We have written c, rho is the radius of curvature. Due to the Poisson effect, we can write E epsilon z, that is minus mu epsilon x, is equal to minus mu into y upon rho. This is change in the y direction. So it means that when the beam bends, we can see from this equation, when the beam is bent in one direction, that is x here, there will be bending in the perpendicular direction also, because there will be also radius of curvature it will form. And initially we can write this one for Ez direction, for Ex direction radius of curvature is y upon rho, so radius of curvature is 1 by rho, this is rho. So and in case of if Ez, this will be bending in Ez also, see this one, so it will bend like this, not only in the axial direction, it will bend in the y direction, z direction and y direction also. So we can write that here this is the y value, original value, and this is rho upon p, we can write. So here the radius of curvature is rho by mu instead of rho. So we can write that the beam bends in one direction x, here there will be bending in the perpendicular direction also. And we show this anticlastic curvature for the z direction in the figure. This is in this also we can show, and this is in this direction also. So in both directions there will be changes also, and we can see that not only in the one direction, if we will bend in the x direction, it will be, that will bend in the y direction also, in z direction also, and we can calculate the radius of curvature in that direction, how much it's bending, using the Poisson ratio, your Poisson coefficient. These are the references. Thank you.